Hi everybody, welcome to my class, and today's lesson we are starting mechanics, which is an external standard and it's worth 6 credits. In year 13 we have made mechanics into 3 little portions. It's all to do with different types of motion, and the first thing we are looking at is linear motion. Once we finish that, we look at rotational motion, and then finally we look at simple harmonic motion. I know the last 2 terms are new to you, we haven't done that before, but let's start with what we know. So we're starting off with linear motion, and the quantity that I'm going to concentrate on today is this term that you have learnt before, and it's to do with momentum. And the reason why I'm starting off with momentum is because momentum has to do with the quantity of motion of a body, okay? And the symbol for momentum is P, and the way that momentum is calculated is it depends on the mass of an object as well as the velocity. Now, velocity is speed with direction, so which means that momentum is actually a vector quantity. And so both the speed as well as the direction is important, and when solving problems with momentum, we need to include direction in those ones. Now, the quantity of motion of an object can either be destroyed or created. And how can that happen? By applying a force. Now, when you apply a force, what actually happens, if the quantity of motion changes, we say that the momentum changes. And it's a force that brings about a change in momentum, and this is where we get the word impulse. So change in momentum, which is represented by delta P, usually the mass doesn't change, and it is the velocity that changes. This is one way. There are many ways of calculating change in momentum. So one way is delta P is m delta v. So if I expand that, it's the same as the final velocity minus initial velocity, mass times final velocity, or mass times initial velocity. The change in momentum, because it's brought about by a force, can also be calculated when a force acts on an object for a small amount of time. It brings about a change in momentum. So this is another formula to calculate change in momentum. So how do we know that the momentum has changed? The object could change its speed, or it could change the direction in which it's moving, or it changes its velocity, because velocity is speed with direction, so it can change both speed and direction, or it could be going in the same straight line, but increasing or decreasing speed amounts to change in momentum. Now, also, this whole thing has to do with acceleration as well, because when you have an unbalanced force causing a change in speed or the direction of motion, this results in acceleration. And the direction of acceleration is always the same as the direction of the unbalanced force, and then going one step more, the direction of the unbalanced force, and therefore the direction of acceleration, is also the same as the direction of the change in momentum. Okay, and that's what we need to remember. Now, these are some of the ways we can calculate change in momentum. There's also a couple of others. So when you have a force that is constant, then you can use P is equal to F delta T, a constant force acting for some amount of time gives a change in momentum. But if the force is changing, then the way that we calculate the change in momentum, we call it an average force if it's a force that's changing. If you draw a force time graph, then the area under the graph, so you can have a constant force or a changing force. If this is a changing force, then the area under this triangle will give you the change in momentum. And also, we've learned from last year, this is just a little recap. If you have a force, 2 lots of force time graphs, a small force acting for a long time can bring about the same change in momentum as a large force acting for a short amount of time. So lengthening the time decreases the force, and this is desirable to prevent damage. Okay, so that's today's lesson. Not a whole lot of new things, but it's just a repetition of what we learned last year, and we're just taking you from there. The difference is, in last year's exam you would have only got solving problems in one dimension, things that's moving at 180 degrees to each other, but in year 13 you do have change in momentum in 2 dimensions. But we actually taught you that last year without really telling you. You don't have it for the exam. So bye for now, and I hope that made sense.